Hello to the UMBC community. I'm Karl Steiner, I'm the Vice President for Research here at UMBC, and I'm really delighted to welcome you back to the fall semester 2020. Standing here in front of our fabulous new buildings, the ILSB, one of the research labs, but we have so many labs and studios here on our campus that are eager to have you back, of course, but it's a different year this year. I am so very proud of how the many members of our UMBC community have responded to this very significant challenge related to COVID-19. We have members of our community, faculty and staff and students, obviously, that are members of our active community, but also our alumni who are fighting the fight against understanding how we can combat the virus and mitigate its wide-reaching impact on the communities that we serve. At UMBC, for many, many years, we have been focusing on not just the research and creative achievement that we conduct, but also the impact that it has on the communities that we serve. We call that public research for public good. And I can tell you, looking at the many activities across our campus, even while we were working remotely from home or under stage 1 research creative achievement mode here on campus with limited numbers of faculty in the labs, the innovation and the commitment of our researchers to find ways to understand and mitigate some of the very difficult situations that many members of our community are facing is just tremendous. And it can only work at a campus like UMBC, where we for so many decades have been closely connected and very integrally interacting with members of our community. So you will hear in some of the other segments that we show you today from some of the researchers, but I also wanted to highlight some of the other work that's going on our campus. University System of Maryland recently launched its first ever app challenge related to COVID-19. And all of us should rejoice that not just one, but 2 of our student teams were recognized for their very innovative contributions to that challenge. One of the student groups is a group of graduate students that is working on an app called Follow Up. And we had a second group of undergraduate students that is developing and working on an app called Snug Grub. So much of our research and creative achievement is continuing as well, and not everything is related to the pandemic. We were just thrilled that a week ago, HARP, the UMBC's first ever satellite, which was launched back in November from Wallops Island, was named as the Small Sat Mission of the Year in the world, with people voting from, I think, 40 countries across the world. And so shout out to Vanderlei Martins, his team in the Earth Space Institute, and our colleagues here in physics on our campus. And next up, you will hear from a number of our researchers who are actively working on projects related to COVID-19.
Hi, welcome to UMBC. I'm Professor Katherine Seley-Radtke, and I'm from the Department of Chemistry and Biochemistry. My research team and I work on developing drugs for various viruses, cancers, and parasites and other diseases, such as SARS-CoV-2 and COVID-19. What drives me to pursue this research is the ability to try to find a cure for diseases such as the pandemic that we find ourselves in the midst of. The reason UMBC is such a great place to work is because I get the opportunity to train fantastic students and help them grow into future scientists.
My name is Charissa Cheah, and I'm a professor in the Department of Psychology. The research project that I lead is funded by the National Science Foundation and focuses on the outbreak of racial discrimination targeting Asian Americans during the COVID-19 pandemic. We wanted to document the different types of racism and racial discrimination experienced by Chinese American parents and their children during this public health emergency through surveys and interviews. We wanted to learn how these experiences both impact parents and their children's racial identity, development, and mental health over the course of a year. We also really wanted to understand and learn what makes some of these families resilient and even thrive under these stressful conditions. My collaborator, Dr. Dipanjan Pan in the Information Systems Department, is analyzing social media data and posts to capture the broader public opinion and social discourse around these issues during the pandemic so that we can really situate these families' experiences within this larger context. What drives me to complete this work? Conducting research is challenging. Conducting research that involves families during a pandemic is very challenging. This is especially so for our team because we're working on a topic that is really close to our hearts, as all the investigators and students on this project are from ethnic, racial, and/or religious minority groups in the US. Every day when I do this work, be it speaking with families or working with my students, looking at the data, analyzing it, thinking through what these numbers mean, what the words from our transcripts mean, writing up the findings, or communicating with community and advocacy groups to share what we learn and to understand their needs further, I'm reminded of why this work is meaningful and how we're just really trying to make our society more just and equitable for all. And it's truly all those things that drive me to complete this work.
COVID-19 pandemic is a global pandemic that has changed the way we live our life. The current demand, and this is true for any country, including the United States, is a rapid, convenient, and large-scale diagnosis of COVID-19 to downregulate its spread within as well as across communities. So there are multiple factors that are preventing the downregulation of the spread. And these are rapid diagnosis that does not require expensive instrumentation or laboratory setup, skilled personnel, and of course, the specificity of the tests. With our approach, we're trying to hit all these clinical unmet needs by applying a highly multidisciplinary approach, which combines material science, nanotechnology, molecular biology, electrical engineering, and medicine.